Right. We've seen service endpoint. Now let's just have a quick overview on private endpoint or in where we can use it. So that will conclude the service endpoint and private endpoints. Now with this service endpoint, the example what we have seen, okay, you can see that there is a storage account. It is still, even though we are restricting access to this storage from the private network, from our virtual network subnet, this storage still have it is still having a public IP assigned to it, and then we can make use of it. We can still give access to the storage to other users who are on the internet who want to access the storage. As to what is the benefit of having the service endpoint? It basically uh, reduces the latency to access your storage. It will be faster because it is building this connectivity over the Microsoft backbone instead of going over the internet. So if it is over the internet, the VM has to access the storage through internet to the storage. So this is the path it will take. But with the help of service endpoint, it will go now directly over the service endpoint using the Microsoft backbone network and access the storage. So definitely in terms of speed, it will be faster, and in terms of security, it will be much more secure than accessing it over the internet. Now, this is the service endpoint. Let's look at the scenario of private endpoint where it will be used. I'm going to draw it again on the board. We might not be able to see the lab for it because it will again take 2 hours for it. Okay, private endpoint. Let's look at the scenario. Let's say we have virtual network again, VNet, one subnet or two subnet, whatever is our setup, and we have a virtual machine. And this will be all the private IP addressing. This is our subnet /16, and this subnet, let's say this will have an IP range of /24 within that network. And this machine will have an IP address, for example, 10.0.1.10. This is the IP address of this virtual machine. We'll also have our on-prem setup here. Say I have an on-prem network. There's a connectivity between these two, and this can be possible over IPsec or express route. These are the two type of connections you can have between your on-prem and Azure, the cloud. So we have our servers again here, the main controller, let's say file server and so on. And we have users sitting here. Desktop users and the laptop users, whatever it is. User one, user two. Right? So from here, from this particular user machine, I should be able to access this virtual machine. Let's say this is my VM1. Okay, so from this user machine, I can access VM1. If I have a file share on VM1, for example, //VM1/fs. This is fine. Now, let's say I have a storage account, and this is all going to be public cloud, Azure. So I have a storage account. I have created the storage file share in the storage name. Name of the storage account is ST Cloud, for example, Cloud FS file server on the cloud. File share. This is a folder I have created on this file on this storage. In the previous example, we have seen that we can activate a service endpoint, right, on this particular on a specific subnet. The service endpoint is enabled and activated on a specific subnet. So you have to do it on the subnet level. And with the help of this, we have seen that the connection to the storage is happening over the Microsoft backbone. With it says the connection remains within the Azure cloud. It doesn't go out to the internet. Now, what is the private endpoint? But still, the difference you have to understand is that this service, the public endpoint, it has a public IP address 175.1.2.3. Okay, for example. So this access is happening over the public IP address. So if you see in our example which we had, you can actually look at the IP address of this. What is the IP address of the storage? Name lookup or ping. There's a storage account name, and that is the IP storage has. See here by pinging this name, host name, it's actually giving me the IP address, and this should be a public IP available on the storage. The difference between the service endpoint and private endpoint is this. So in service endpoint, we are creating a service endpoint on subnet level, and storage will still have a public IP assigned to it. Okay, the connectivity will happen over the private channel, the Microsoft backbone. This is the backbone connectivity between the network, virtual network, and the storage account. Now, with the private endpoint, what you can do is just look at the difference now. Now, for that, we'll not create service account, service endpoint. We don't need the public IP also. What do we do with that is we create a virtual network interface card. Okay, so this is a subnet. In this subnet, we have this virtual machine one. Similarly, you can create a private endpoint. So this private endpoint will have actually a private IP address assigned. So let's say PE, we can name it. It will be actually a network interface card. It will be a NIC created on this VM on this virtual network subnet. So the name will say PE storage. I can name it anything, and this will have an IP address 10.0.1. For example, 11. Look at this. It will be the same subnet as this one. And this PE, the private endpoint, will be actually mapped to a specific service. So this is basically representing the storage account on your network, on your virtual network. So for the end users, for example, here, let's say I have a file share here on the storage, right? So in the DNS, I can create an entry. In my DNS, I can say, okay, create an entry with this name, file share, file server, and this should map to the IP address 10.0.1.11. What is the 10.0.11? That is the IP address which I have assigned to private endpoint. Okay, so now for the user, it will be the user will be accessing this private endpoint with the host name. You can access the host name, for example, file server slash the file share name, FS, for example. So what is happening now? The storage, which is a public service, which is a platform as a service for Microsoft, you're able to map that, create a path, private path on your Azure cloud network, virtual network, and that can be accessed from your on-premises network from the user side. So when you type in this in the path, when the user types this, it will actually translate to this IP address. The connection will come here. So the storage connection will work like this. So this will be translated first of all from DNS. It will come here to this private endpoint, and let's see the colors, red or some other color. So this will be translated to this IP. So the private endpoint will in turn connect to the storage. So for user, he will not know where the file server is residing, whether it is on-prem or on the virtual network, or it is a storage account in the Microsoft network. So this whole connectivity is happening on the private network. So for you, for the user, he's sitting in the on-prem network. He is accessing this file share. That file share is accessible. This IP address, it's actually mapping to the IP address 10.0.1.11. The connection, your routing networking will, and the networking will have a connection routing defined. That this network is here. It will come here, and the VNet it will find that this is a private endpoint, and this private endpoint will connect you to the storage accounts. And this is all happening in the private network zone. So this is your private network, right? This is a VPN connectivity, a tunnel, and then from here, from the PE, you have another private connection which is happening over the Microsoft backbone. So you're able to access a Microsoft platform as a service, any service which Microsoft provides to the customer, software as a service, platform as a service. You can access that over the private IP address. You're using the private IP address. You're creating something called private endpoint in your virtual network, and that you can access from anywhere, from your on-prem network or from your virtual network. That's the difference between the service endpoint and the private endpoint. Now, service endpoint is free of cost, and private endpoint, they will charge you for the data transfer between this network, between your virtual network and the Microsoft storage account. They charge you based on the data transfer on this connectivity. Okay. So there'll be scenarios again where you want to use that. I've given a very basic one for your understanding, and there is a lab. You can do that on your own. So
Yeah, this one was on seeing. Yeah, whiteboard,
uh,
until whiteboard it was visible. Okay, now okay.
okay, so what I'm doing is I'm just going to get rid of this resource group, which has too many resources we created for this lab service endpoint that has public IPs, virtual machines, subnets, storage. So I need to get rid of this. You have to do the same when you're doing the labs, and you can even do apply force delete for selected virtual machines. You can do the force delete as well, and that will stop your billing on the virtual machines and the resources which you are billing. Okay, so let's continue the slides. Right. Are you able to see the screen now? The slides.
Yes, yes.
Okay, let's continue. Now, these are some of the advanced topics we are going to cover in networking, virtual networking. And for that, you need to have a basic understanding of OSI layers. And I'm sure you should have that, because that's fundamental for understanding these topics. We're talking about firewalls, or web application firewalls, application gateways, and so on. So just to brief, I've just added a couple of slides for your understanding. OSI model was OSI layers. We talk about OSI layers. OSI model was developed by ISO. This is again an international organization for standardization. Why it was created? ISO created the OSI model to standardize how different systems communicate, all vendors to build interoperable network products, provide a common language for teaching and troubleshooting networking. Okay, OSI layers are a seven-layer model that explains how data moves from one computer to another over a network, from physical cables up to the application. So basically, it is a conceptual model, a theoretical model used to understand, design, troubleshoot networks by separating communication into seven logical layers. And this is what the OSI model looks like. And you can't really see this practically happening with your own eyes, but logically, this is what goes on in the network. So when you see here, there's an example of device A talking to device B, right? So how does the data flow from one machine to the other machine? This is what this diagram is explaining, right? So these are the seven layers of OSI model, starting from down layer one till layer seven. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. So when you are accessing, for example, you as a user on device A accessing an application, let's say device B is a web server. Okay. You want to access that web server. What do? You open the browser, you type in the URL and the website name, and that data transfer, how it is happening, that connectivity and the data transfer, it actually happens in these layers, different layers. The data transfers on HTTP protocol over the browser. It crosses the application layers. It goes to the transport layer where it decides which protocol to use for transferring the data, TCP or UDP, and then it goes on to the network layer wherein it uses the IP addressing for reaching the destination host. Data link there is mainly for MAC address, network interface cards function on this layer, which will have the MAC address. And then it goes on to the physical layer, which is basically your physical wire or the wireless network. So your data transfer actually happens in this ones and zeros, right? And then when it reaches the other computers, the same process, the OSI layer, seven layer, like from device A, it followed the uh, communication path from layer seven to layer one. It goes in reverse now. So first, the data reaches the physical layer, your network interface card, wireless or wired over the wireless or wired network. Then it goes to the network interface card. From the network interface card, it goes to the network layer, then transport layer, session layer, presentation layer, and the application layer. So this is your these are very fundamentals, but you have to understand the OSI layer model in order to understand the topics which we are going to discover, right? So you should I hope Junaid has studied this in his bachelor's OSI layer model. This is very fundamental topic in computers, and I have just included few points for your understanding. Layer 7 protection. Now, in when it comes to Azure, we don't really we are talking about Azure admin and designing syllabus, right? And the course, what we are learning here. So it doesn't really go down deep down in each explaining you each layer, OSI layer, and give you the details on it. This is something you have to do. So here it straight away goes on talking about layers, all the layers, what works on what layer. So layer 7 protection in cloud computing or in even on on-prem scenarios, you will hear people talking about layer 7 protection. What exactly layer 7 protection means? So if you look at this again, I'll show you the first three layers which you see. I'm not sure if I can write on this. Let me bring that attachment, the file which I have. I'll use the whiteboard to explain you. Okay, let me get that image. Right. So if you are able to see this image, second, let me maximize it. Right. So you see these first three layers. These layers collectively called as application layers. Okay, and basically it includes application, presentation, and session layers. So what works on each layer, you should do some homework. But here in the cloud, when you talk about the firewalls and the application firewalls, the web application firewall mainly deals with these three layers. Okay, so
I can see only.
okay, this is what I was explaining you. So if you see here, these three layers are mainly considered as layer 7 protection. The WAFs, when you talk about web application firewall, they mainly deal with these three layers, and these are called application layers. Collectively, they are called as application layers, right? And you will have web application firewall, which can understand all these three layers and block traffic or allow the traffic based on those. And when you talk about the regular firewalls, layer 4 to layer 3, this is where your this is basically transport layers, and your regular firewall without any uh, application monitoring. The plain network firewall will be looking at these two layers. It understands basically the TCP and UDP protocol, and it understands the IP address and the ports. So for the firewalls, if it is just a network firewall, it is called layer 3 firewall or layer 3 and layer 4 firewall, which understands TCP, UDP protocol, IP addressing, and the port numbers. So when you create a firewall rule, you can do the firewall rules based on only these particular uh, components. And when you talk about a web application firewall, your web application firewall uh, functions on these three layers, application layers collectively, wherein you can see based on the application HTTP or HTTPS, based on the application specific applications, you can filter the data. You can encrypt and decrypt the data as well with the help of SSL inspection. So it can also decrypt traffic, and it can work on the payloads. Can check the payload or the data which is being transferred on those particular sessions. So let me go back to the slides. I'll explain you this. This is what I mean here. OSI layer 7. When you say layer 7 protection, it's nothing but controlling. It's about the application layers, all three layers. It's not just layer 7 protection. This is what I've mentioned here. Application layers combined in practice. So basically, application, presentation, and session. These three layers are protected in the layer 7 protection in the cloud and even on-prem. We use a common terminology to refer to this as layer 7 protection. That means your firewall understands HTTP methods, get, post. If you have worked on those web server in the what do you say, in basic web development classes, you will understand what is the get and post commands. How does it work on HTTP connection? You can also inspect the URLs, headers, payloads, You can actually see what data is being transferred. Presentation layer, it actually takes care of encryption. So web application firewall can also understand different encryption mechanisms, and it can decrypt the traffic and see what data is being transferred. So it can even convert encrypted traffic into readable form. This is what it says on the presentation layer. And the session layer, it tracks user sessions and connections. So it knows if a request belongs to an existing session. So modern security tools like WAF, it processes all three together. So they are commonly called as layer 7 protection. So this is why I needed to highlight you what exactly the layer 7 protection means. So the layer 7 protection means it's the component, the device, or the application which provides you layer 7 protection. It should be able to understand all these three layers. What is happening on these three layers? So it will be a HTTP connection traffic presentation, whether it will be a plain text or whether it is a plain text or encrypted traffic sessions. It will see if the session is it basically it does the session management, whether it is the existing session or the new session, it takes care of that. So you will have granular control, and then you have the firewalls, which is taking care of next two layers. Well, you can define the firewall rules like we did in NSG, network security group rules. We created a rule based on the source destination and the protocol and the port number. So similarly, in the firewalls, you can do that. So nowadays, these functionalities are clubbed in most of the products. You will have WAF, firewall, all this together built into one particular solution. So but again, when it comes to the enterprise networks, these will be separated for better performance and management and the audit purpose. So you'll still have separate WAF or the web application firewall taking care of the first three layers, and you'll have the network layer three firewall which will take care of the next two layers, transport and the network layer. So layer three and four protection firewall without application controls works at network and transport layer three and layer four does not understand the application. So if it is a firewall without any application controls, it does not understand if the traffic is encrypted, because the encryption is happening on which layer encryption happens. Junaid, layer 7 or layer 6?
Yes,
Are you following me? Or are you
yes,
sleeping?
yes. No, no.
Which layer, where on which layer the encryption takes place? Application or presentation or session?
Presentation layer.
Presentation layer. Yes.
Yes.
So the encryption happens on the presentation layer. And so if you are having a firewall which only works on layer 3 and layer 4, it won't be able to see what data is being transferred on the session. So it cannot, if the traffic is encrypted, it cannot really see what is inside that packet. So it only looks at the source destination. So you can see here that it does not understand the applications, does not inspect HTTP content, makes decision based on source IP, destination IP, port, and the protocol. So that's what the firewall. That's how the firewall works. Firewall processes network and transport layers together. So they are commonly called network layer firewalls, making decisions based on IP ports and protocols, not application content. That's the reason we have web application firewall, which takes care of the first three layers. Then now we are having topics about load balancers. Azure has the solution for load balancing as well. What does the load balancer do? A load balancer in Azure is a service that distributes incoming network traffic across multiple virtual machines so that no single VM gets overloaded. Your application stays available even if one VM fails. Traffic is handled efficiently and reliably. So let me give you a quick whiteboard overview of load balancers. We have seen virtual machine scale sets. Does anyone remember VM scale sets?
Yes.
What is the VM scale set? Or
It's a
VM
scale up or scale down method for the VMs.
availability set. These are two different things we have seen. Scale set is used for auto scaling, right? It's used for scale up and scale down. Scale in, you can say. Scale out is scale in, not up. Those are the terms which we use here in Microsoft. Basically, scale out and scale in. That means based on the resource requirement. So what happens is, let's take an example. Let's say I'm creating a virtual machine scale set, VM1, and I'm also creating VM2. So when you're creating a scale set, it will like create two virtual machine scale sets, two virtual machines at least. So these are part of scale set. Right. Now these machines will be identical in configuration. It will be identical in terms of application and the data as well. Then only it is going to work, right? So for example, if this is a web server, let's say this is my web server. This is also my web server. So whatever data I have here on this web server, I have home page, I have some JavaScripts, I have some DB connections, backend connections. So I should have the similar configuration here. Otherwise, my scale set doesn't work. There's no point having the scale sets. So this scale set, the second VM is basically the copy of the first VM. So this is my scale set. These are my front-end servers. In the multi-tier architecture, this is my tier 1, and my tier 2 is basically the database servers. It can be one database server or multiple database server, sub to use. DB1, DB2. So these web servers will be basically connecting to the database servers. Now, how do you do the load balancing? This is my web server 1, VM1 and VM2. For me as a user, if I'm on the internet, okay, I'm accessing my website. Why it is going shorted? Are you able to see what I'm writing? It's very dim actually. I think the pen quality is gone bad. So abc.com, it's my website. So when I host the website, I know I need a DNS record. This DNS record will have the mapping of my website to IP address. It will map to my public IP. For example, 172.123, for example. Let's go with that. Right? So that's my typical web server setup. So when the user tries to browse the site abc.com, it will look for this IP address. It returns this IP to the user, and user will connect over the internet. The internet knows where this IP is, where this to whom it belongs to. So basically, this is an Azure IP address, which is assigned on our virtual network, public IP. So here I'll have that IP, public IP, 172.1.2.3, right? But it will be assigned to, it will be mapped by default, it will be mapped only to one virtual machine. Cannot map it to two different virtual machines. Okay. So let's say what happens in this scenario. Users trying to access abc.com. He gets this IP address. He, he finds that okay, this is the IP of the website, and this connection goes over the internet, and it lands here to the Azure. And Azure configuration, you have this IP basically mapped to the virtual IP address of the server. So let's say that this server has 10.0.1.1.10, and this server has IP address 10.0.1.20. Right? So the traffic comes here, it will land on this particular web server, and the website works fine. There's no issue. But what happens if this VM is down, right? Even though you have a scale set configured, but on the upper layer, on the ingress path, in the incoming traffic path, you don't have any mechanism which is making sure that this traffic is load balanced between these two virtual machines. The reason you're creating multiple virtual machines is to balance the load, right? The internet traffic load, and to make sure that if VM1 fails, your website is still up and running and accessible from VM2. So for this scenario, you need something called load balancer, right? This is where the load balancer plays the role. What will happen is we'll deploy a load balancer. Let's remove this part. We'll configure Azure load balancer. Okay. This load balancer will have the IP address assigned, the public IP which is given to our website. Okay. So the connection from the user, it will come travel over the internet and land on Azure load balancer. And it is a job of load balancer to establish a connection to the web server. So now it has, we know while we are configuring load balancer, you will see we have two web servers, so we can configure the load balancer in such a way that this traffic is first of all load balance. That means there are 1,000 users accessing our website, so the load will be equally balanced. So you will say 500 users will be connected to this, and 500 users will be connected to this server. So for any user, you won't know which server your session is landing on. But for us, we know that we have a load balancer and it will balance the load between these two servers. And in case of failure, if the web server one goes down, let's say this server is down, load balancer will keep checking the status of the servers, and it knows that okay, this server is down, so I should not be sending any more connections to it. Instead, I will send everything to VM2. This is the job of load balancer. Is that clear? Any doubt here? Raja and Junaid.
It's clear, clear.
Right. So that is the basic, very basic concept of what the load balancer does. So these are the points. No single VM gets overloaded. Your application stays available even if one VM fails. Traffic is handled efficiently and reliably. Now there are different products available for Microsoft for load balancing as well as uh, for the security. You have Azure Load Balancer. You have Application Gateway that's also functions as a load balancer. You have front load and you have traffic management. So these are basically all the load balance types, and there are different there are differences here. If you see again the OSI layers, it's very important for you to understand the difference between the OSI layers. If you talk about Azure load balancer, particularly it works on layer 4. That means it understands the TCP and UDP packets. Based on the IP, you can decide the load balancing. And the type means regional means the load balancer is deployed in the region, in a specific Azure region. It won't be available globally. VM load balancing, internal and external. So load balancers you can deploy in two different scenarios. One is internal. We have seen here in this scenario. Let's get back to this. Okay, this scenario we are load balancing the virtual machines front end. Now, if you want the high available website, you also would like to have your backend. This is the front end, right? Your tier two is nothing but the backend, your backend service. Now, your website might be running fine, but for some functionality of the website, you will also need to make sure that your database servers, which is on the backend tier, are also highly available. So what you can do is you can also introduce one more load balancer between your front end and the backend. So let me see this, clear this one. Oh, okay, I put it here. So in this path, you can also put one more load balancer. Right? It's I think too big. Okay. So let's say this is another load balancer. So you can have two load balancers, one for the front end, which is public facing, facing to the internet, and one is backend load balancer, which is the internal load balancer. So this is called internal load balancer, and this is external or the public load balancer. Public or external LB. So now in this scenario, you have your whole setup highly available from front end to the back end. So VM1, VM2 will be highly available with the help of load balancer, external load balancer. And when VM1 or VM2 needs access to the database servers, those database servers will also be highly available with the help of internal load balancer. So this load balancer will again balance the traffic between these database servers. And also, if in case of a database server failure, it will still serve the web content to the users. So this becomes a highly available architecture for your web servers. Right, so you can have internal load balancer as well as the external load balancer. The only difference is that the placement is important. So if you are placing it facing into the internet, that is called as external load balancer, and you're putting it inside your network between the virtual machines, between the front end and the back end. It is called as internal load balancer. We'll see what application gateway, front door, and traffic manager does in the later classes. So let's focus on load balancers. Here, there's an example here. Again, it is showing like this. Right. So you can see here the same thing what I've explained you. Public load balancer. A public load balancer has a public IP. It is used to distribute traffic coming from internet to your backend VMs. So this is a public load balancer. Internet users, they'll be connecting to public load balancer. We'll see in the lab how we can deploy this. So the public load balancer will basically have, it's actually just the name difference. You see here, there's a public load balancer. Here it says internal load balancer. As I told you, it depends on the placement where you're putting the load balancer. And when you're putting a public load balancer, it will definitely have a public IP, which will be available to the internet users. So your website will be mapped to that public IP address. The traffic for the website will land on the public load balancer, and load balancer will make sure that the traffic is distributed, equally among these two web servers for load balancing. And if one of the web servers is down, it will make sure that your website is highly available, right? So this is one segment of your network. We call it front end tier. So this is a multi-tier architecture for your website. This is tier one. Now from the web servers, in order to make sure that all the features of your websites are working fine, because web servers usually have different contents. One is the a static content which will be available on the web server itself, and some content will be dynamic, which will be stored on the database servers. So front-end servers requires access to the backend server to make sure that your website is 100% functional. So you can also deploy a load balancer here in the backend pool for your backend servers, and this will work on private IP address. So this is the only difference. Otherwise, when you're deploying or configuring the load balancer, it is one and the same. The configuration remains the same for this and this. So it only matters if this has a public IP, it will become a public load balancer. If this has a public private IP, becomes a internal load balancer. So the traffic will be again distributed among two database servers. And in case of a database server is down, one of the servers down, it will make sure that your database server is highly available. So this is called multi-tier architecture. Use cases, web servers accessible from the internet. So you can see here your website. It doesn't directly go to the Azure VMs. It goes through the load balancers. User on the internet, public IP address, load balancer. It can be two virtual machines. In our scenario, it is just two in this example. It can be more than that, depending on the load you have on the website. So if you have this web servers configured as auto scale set, depending on the load and the rules which you have configured for the scaling, it will keep on adding the virtual machines. But it doesn't really matter because load balancer will automatically know that, and it will distribute the loads among those VMs. Okay, what is the time now? We have 15 minutes. So we can probably see the demo as well if we want to see. Let's see one more slide, what we have. Okay, internal load balancer. We have already seen has no public IP. It is accessible only inside your virtual network. Traffic comes from internal applications. Use cases, backend application servers, database servers, internal APIs. So this will not be exposed to the end users. This will be only accessible by the servers. So you have your web servers, which are in the front end as per the architecture tier one, and those web servers will have equal access to all the database servers. That's your internal load balancer. And load balancer comes in different SKUs again. SKU in Azure nothing but the specification, specs or size of a resource. You can see here when you're creating the load balancer, you can give it a name. You can choose what SKU you want. There's a standard and there's a gateway. So the standard one, it says distribute traffic to backend resources. The second one, it says direct traffic to network virtual appliances. This is different. We'll talk about this later. What we are concerned here is the standard load balancer. And here you can see just by selecting this, you will make your load balancer as a public or the internal. So when you select the type public, it will have a public IP assigned. And when you select the internal, it will have the internal IP only. And you can also make it as regional load balancer or global load balancer. We'll see that on the whiteboard. What does the regional and the global means, right? So here it says standard load balancer, high performance, internal or public, IP based or NIC based, inbound and outbound, health probes, TCP, HTTP, HTTPS. What does it mean by health probes? You have seen in the previous scenario. So the load balancer keeps checking the health of the servers. So if it is a public load balancer, it keeps checking the web servers keep alive. That means if the server is still responding or not, right? Those are called health probes. It's called health probes. You can create the load balancer rules as well. Public or private load balancer, whatever it is, you can create the rules. Defines how traffic from a front-end IP or the port goes to the backend VMs. Controls which protocol and ports are used, TCP or UDP. Supports option like session stickiness and floating IP. We'll see this in the next class, what exactly this means, session stickiness and floating IP. You have another slide here which explains you a bit about session persistence. What does it mean? The same user is always sent to the same backend VM. If you see here, this represents a user, right? This user has three connections established, connection 1, 2, and 3. And when it reaches the load balancer, each connection is going to a different backend server. You can see this. So 5 tuple hash, that means source IP, source port, destination IP, destination port protocol. Based on these 5 parameters, it maintains the sessions. So since your VM virtual machines will be having the identical data, the user will get the same content back as it is trying to access. So that's why when you create the skill set, your VMs must have identical data. If it is a web server, it will definitely create a copy of that web server and multiply it based on the demand. It keeps the session sticky, so user does not data is not lost. So once your connection is established, and let's say you then we have Azure Application Gateway. So we'll keep this for the next session. Uh, First, we'll see how the load balances works. In our next session, when we start on the next Saturday, inshallah, we'll start with the labs of for the load balancer. So in the lab, we'll see how the load balancer works and how we can build the three-tier architecture for making sure that the website is highly available, right? So we'll end our session today here. If you have any doubts or anything to ask, please go ahead.